All right, on this Chapter 6 homework problem, we are going to be looking at costs that are either fixed, variable, or mixed. So they give you a chart. It says you have the following chart shows three different costs. You've got cost A, cost B, and cost C. It says for each cost, the chart shows the total cost per unit at two different volumes within the same relevant range. Based on this information, identify the cost as fixed, variable, or mixed. So you'll notice right away, here's the volume. There's the 1,000 units, and then they showed the different volume at 4,000. Now, notice you've got a total cost and then cost per unit for each of these. Now, if you're curious how they come up with the cost per unit, you simply take the cost and divide by the unit. So for example, they would have taken 75,000 and divided by 1,000, and that's how they got the $75 per unit. And then they also took 75,000 and then they divided that by 4,000 units and they got 1875. So for each of these, they always took the dollars and divided by the units. So the rules are for cost A, what we want to look at is, first of all, let's look at the total cost. The total cost is 75,000 at 1,000 units and 75,000 at 4,000 units. And so right away, because the cost did not change, you're going to say that's a fixed cost. And also look at the per unit. So the rule for per unit fixed cost is it's variable and it goes down as activity goes up. So there's an inverse relationship. Notice it's $75 at 1,000 units. And notice as the volume goes up, the per unit went down. So that's the definition. That's a characteristic of a fixed cost. So cost A would be fixed. Down below, you'd say it's a fixed cost. Total cost stay the same, per unit cost decrease. On cost B, look at the total cost, it's 6,000, and notice how it changes. It goes up to 24,000. So right away I'm thinking it's either going to be variable or possibly mixed, but it's definitely not fixed. Now, look at the cost per unit. It's $6 at 1,000 units and $6 at 4,000 units. So by definition, that's going to be a variable cost, because variable costs per unit are fixed. And also the total costs go up or down with volume. So cost B would be variable. The total cost increased because the volume went up, and the per unit cost remained constant. So that would be the definition of a variable cost. Now, cost C, let's look at the total cost. You got 32,000 and then 68. So right away, we know it's not fixed. It's possibly variable or mixed. So the key will be looking at the per unit. So $32, and then, oh, there we go, 17, it changed. So because the 32 did not stay the same, this is going to be the characteristic of a mixed cost. So cost C is mixed, the total costs are not constant, and the per unit costs are also not constant. Okay, again, we are going to be looking at cost structure, variable cost, and fixed cost. And so in this problem, we've got the Top Care brushes produces a premium hairbrush. They give you the total manufacturing cost of $250 when they produce 20,000 brushes. It says of this amount, total variable costs are 80. What are the total production costs if they were to produce 25,000 units? So when you start off by saying total cost, if the total cost is $250, and that's at, I'm going to write this out, 20,000 units or brushes, and they told you of this amount, they're telling you that 80,000 of it is variable. That means that the other part of it, most likely, we're going to have to estimate this, but we're going to say we're going to go with fixed. So the difference there would give you 170,000. So the difference between 250 and 80 would be 170. So we would predict that the fixed costs are at 170. Now, we also want to do something here. So the fact that we've got 80,000 variable, you want to go ahead and divide that by the 20,000 units. That's going to give you a variable cost per unit of $4, because that's going to be the key to this problem, is that the rule to variable cost per unit is that the per unit is fixed. It does not change within a relevant range. So at 25,000 units, you would multiply that by $4. So you would estimate that the variable cost are 100. And of course, we already know the fixed cost, which we estimated that to be 170. So we would predict then that the total cost at 25,000 units would be 270, and that's what you'd come up with. So again, This is your variable cost part of it, and then your fixed cost, you just add them together, and then of course that would give you your prediction of 270. On this problem, we are going to be looking at the high-low method, and it says use the high-low method to determine the variable cost and fixed cost components of quick changes operating cost. Use this information to project monthly operating costs for a month in which the company performs 3,800 oil changes. So I went ahead and opened up the icon. They give you the range of data here. Notice it's January through June. So the way I do these is I'm going to write down below, you've got the high point and the low point, and then I'm going to write the units, and then I'm going to show you the dollars. So just simply pick a point. So the high point on all these looks like it's right at 4,000 units. And that's at $35,500. And it looks like the low point is going to be 3,000. So I'm going to write 3,000 there, and then 30,500 is the cost that goes with that. So the first thing we do is once you have identified the high point and the low point, you take the difference. So what we're doing is we're establishing the range. So 4,000 minus 3,000 would give you 1,000, and 35,500 minus 30,500 would give you 5,000, and that's dollars. So once you've taken the difference there, then what you do is you divide. You take the $5,000 difference, divide by the $1,000 difference of volume, and that's going to give you $5 per unit. So up here, that's going to be called your variable cost per unit. Now, the next step then is to figure out your fixed cost. Now, and when I do my lecture course, I often go over the linear equation, so I'm going to write this out up here just to kind of give you an illustration. So most of this stuff follows a line path. So if we can project that letter Y would represent total cost, letter A would represent your total fixed cost, and then the B part of this equation would represent your variable cost per unit. And then finally, the X represents whatever activity volume you're using. So what you do is you just plug into this equation either the high or the low point, and you're going to back into your fixed cost. So I always choose the high point, doesn't matter. But if the high point, you've got 35,500. Again, I'm pulling that right from this high point. You're going to say that's going to let that equal Y equals A plus $5, which we already calculated, multiplied by 4,000 units, because that's the high point. And at that point, 5 times 4 would give you 20,000. And of course, if you look down here at what they're showing you, that represents your variable cost. You then subtract that from 35,000, and you're going to get 15,500 equals letter A. That's going to represent your fixed cost. Now that you've got that, you can put this into your equation. That's what this equation is right here. Notice it's going to be Y equals, okay, and you've got 15,500 as your total fixed cost plus 5x. Even though they kind of wrote this a little bit differently. They said 5x plus 15,500 is the same thing. And then the last part of it is you just have to plug in 3,800 into x. So you'd have Y is equal to 15,500 plus 5 times 3,800, and then that's going to give you a predicted cost of 34,500. All right, another high-low method example. And so it says in past records, they showed that the total overhead cost, that's your total cost, was 25,400 when 830 hours were worked, and 27,900 when 930 hours were worked. It says if Yummy Catering has 855 hours scheduled for next month, what would be their expected overhead cost? So we're going to have to assume in this problem, if it's high-low method, that these are the high and low points. So like I did in my previous illustration, I'm going to write out the high point, units, and dollars. So at the high point, it looks like it's 930 hours, and that's at $27,900. And the low point would be 830, and that's at 25,400. And once again, you take the difference, so you get 100, and then in this case, you're going to get $2,500 as the difference. Then you divide 2,500 divided by 100. That gives you $25. That's a per unit. That's going to be called your variable cost per unit. So then I go to my equation, I just go y equals a plus bx, and I pick a high point because I'm going to solve for my fixed cost. So 27,900 is my total cost at the high point, plus a plus $25, which is my variable cost per unit, and then multiply that out by 930. You're going to back into a. So your total variable cost, I'm going to write this out as 23,250, and then you subtract, you're going to get 4650 equals a. Notice that would be your fixed cost. So then look at the equation. Y is equal to, and however you want to write this, 4,650, which is your fixed, plus 25x. They're showing 25x plus 4650, same thing. And then the last step, you plug it in. You say y is equal to 4650 plus 25 multiplied by 855, because that's the volume you're wanting to use, and you're going to get $26,025 as your predicted cost. All right, for this problem, we are going to be looking at the two different income statements. They call it the traditional or the GAAP income statement and the contribution margin income statement. So in this problem, they give you that this is a quilt shop. They make quilts. It says that they buy the quilts from a local Amish artisan for $290, so that's going to be their cost, and then they sell them at $490 each. They also pay a commission of 8% of sales revenue, and then it says they lease their shop for $1,300 per month, and then they pay $1,800 per month in payroll cost in addition to sales commissions. So that's the setup. Now, they sold 95 units or quilts in February. First thing we'll do is traditional income statement, and then the C and the contribution margin. So down here, looking at the traditional, notice the format is your sales minus cost of goods sold equals gross profit. And so to get the sales, you've got the 95 is what they sold, and you're going to multiply that by 490 because that's the sales price. That gives you sales revenue. So in that case, that would give you $46,550. Now, so I'm going to write sales at the side here. Now, the cost of those sales, they told you, was $290. So 95 multiplied by 290 is going to be your cost of goods sold. So that would give you the $27,550. That's where they got that number. So then you subtract, and you get gross profit of $19,000. Now everything else is going to be your operating expenses. So to get this sales commissions, you have to take it's 8% of sales revenue. So if you take 46,550 and multiply that by 0.08, there's your 3724. They told you that they have payroll of 1,800, so that's, you just plug that in, and then they got a lease of 1,300, and then you just plug that in, and then of course you subtract all of these, and you're going to get operating income of $12,176. Okay, so on the contribution margin income statement, it's going to be looking at variable cost and fixed cost format. So notice the sales is going to stay the same, and then the next group is you want to come up with your variable. Well, your variable costs are going to be, in this case, cost of goods sold, which we've already calculated. So to remind you, we took 95 quilts, multiply that by 290. So your cost of goods sold is $27,550. So that's going to be a variable cost. And then your sales commissions are also variable. So your revenue was $46,550 times 0.08, and that would have given you $37,24, and that would have been your other variable cost. So sales minus variable cost equals contribution margin, and then everything else is fixed. Subtract out your fixed cost. You've got payroll of fixed, which is $1,800, and you got the lease, which is fixed, which is $1,300, and then there's your operating income of $12,176.